All right, let's just dive right in. I want you to imagine a world out there in the cosmic dark, a place so incredibly alien that a single night could last for months, maybe even for years. Now, this isn't something from a sci-fi movie. This is a real place, a giant in the making, and today we're going to take a trip there. We're going to a world that's literally rewriting the rulebook on how planets are made, and it's challenging everything we thought we knew about the universe.
And I'm not exaggerating. This is a real world that scientists are watching form right now. It's like a snapshot of cosmic creation frozen in time for us to see. And what they're finding is forcing them to rethink the most basic ideas of how you build a planet. Seriously, every new bit of information we get from this place pushes the boundaries of science and makes us question the story of our own cosmic backyard.
So that's the big question, isn't it? I mean, in a galaxy with trillions of planets, what does it take to get a title like one of the strangest ever found? Well, it's not just one thing. It's this perfect storm of weirdness. Its unbelievable size, the fact that it's just a baby, the chaotic and beautiful stellar nursery it calls home, and of course, that deep, deep mystery of its endless night. So here's our game plan for unpacking this cosmic puzzle. First, we'll get to know this world of endless night. Then we'll check out the star and the cradle it's forming in. We'll solve the mystery of that crazy night cycle, see how a giant planet is actually born, look at the tech that lets us see it, and finally, we'll understand why this bizarre world is actually a window into our own past. All right, let's get into it. Our subject's official name is HD 100546b. Yeah, I know, not exactly catchy, is it? But that clunky name belongs to a true cosmic puzzle, one that's challenging astronomers in all the best ways and pushing our technology to its absolute breaking point. Now, this place isn't exactly next door. To get there, you'd have to travel 320 light years. Let's really try to wrap our heads around that number. A single light year is almost 6 trillion miles. So we're talking about a journey of nearly 2,000 trillion miles. If you hopped on the fastest spaceship we've ever built, it would still take you millions of years to get there. We are literally looking across an ocean of space and time to a faint constellation called Musca, the Fly. So to put this thing in perspective, think about Jupiter, the undisputed king of our solar system, so big you could fit all the other planets inside it. Well, HD 100546b makes Jupiter look kinda small. We think its mass is somewhere between 6 and 12 times Jupiter's. It's a true monster, a super Jupiter. And its orbit? It's just as wild. It circles its star about 47 times farther out than the Earth is from our sun. Our most distant planet, Neptune, is only about 30 times that distance. This thing lives way out in the cold, dark fringes of its system. A planet like this doesn't just pop into existence. You need a very special environment for it to grow, a kind of cosmic nursery full of raw materials. So to really get the planet, we first have to get to know its parent star and the place where it's being born. The star itself, HD 1054.6, is a beast. It's a B9 V-type star, which is just a fancy way of saying it's a lot hotter, brighter, and bigger than our sun. But the really critical detail, the thing that makes this whole system a jackpot for us, is its age. It's only about 10 million years old. I mean, in cosmic terms, that's brand new. Our sun is a middle-aged 4.6 billion years old. This star is a toddler, and its youth gives us this incredible, fleeting chance to see a planetary system being built from scratch. So surrounding this baby star is this huge spinning disk of gas and dust. It's called a protoplanetary disk. The best way to picture it is like a giant cosmic construction site. It's got all the raw materials, all the gas, all the dust that you need to build planets, moons, the whole shebang. This disk is the planet's cradle, it's the all-you-can-eat buffet it's feeding on, and it's the very reason it exists. Okay, let's get to the heart of the mystery, the whole endless night thing. How in the world does a planet have nights that last for months, maybe even years? I promise it's not magic. It's just a wild combination of physics and just insane scale. Think about our 24-hour day. Sun up, sun down. It's baked into our DNA. It's our most basic clock. Now, I want you to just take that whole concept and throw it out the window. On HD 100546b, that familiar rhythm is stretched to a point that's almost impossible to imagine. We're talking about a single night that could last longer than our entire year. A night so long that whole generations of insects could be born and die before the sun ever rises again. So how does this even happen? Well, it's a recipe with a few key ingredients. First, the planet's orbit is just enormous, way, way out from its star.
Second, because it's so far out, it moves at a cosmic snail's pace. Its year would take centuries to complete. And third, and this is the real kicker, if it has a significant tilt on its axis, kind of like Earth does, that tilt would point huge parts of the planet away from its star for massive chunks of its long, slow journey. Put it all together, and you get these incredibly long, deep freeze seasons and the endless night.
And the consequences of that are just staggering. Can you imagine the temperature just dropping for months and months during a long, dark winter, plunging to hundreds of degrees below zero? And then, as the planet finally swings around, the long summer starts and the sun never sets. For months, that huge temperature swing would drive weather systems on a scale we can barely fathom. Storms bigger than our entire planet, powered by the slow, extreme beat of its seasons. But beyond those crazy long nights, this planet is a scientific treasure because, well, it's not finished yet. This isn't some ancient relic in a museum. This is a live performance. We are literally watching the birth of a gas giant play out across hundreds of light years, a process we've only ever been able to guess at with computer models until now. Because it's still growing, its technical name is a protoplanet. Think of it like a planet embryo. It's still pulling in gas and dust from that disk, and it's still glowing red hot from the energy of its own creation. And this is so important because it lets us test our biggest ideas about how giants like Jupiter form. Do they build up slowly around a rocky core, or do they collapse really quickly out of a big clump of gas? This planet right now is a living laboratory that can help us finally figure it out.
So how do we know it's still growing? We can see the evidence clear as day. Its massive gravity has acted like a cosmic snowplow, carving a huge, empty gap in that disk of gas and dust. We can actually see a glowing, super hot spot on the planet where material is literally slamming into its surface and making it bigger. And maybe coolest of all, we can see these beautiful spiral arms in the disk, like ripples in a pond, stirred up by this giant baby planet as it orbits.
Now, being able to see all of this from 320 light years away is, well, it's an absolutely incredible feat of technology. Trying to look at this system is like trying to spot a tiny firefly buzzing right next to a giant blinding searchlight from hundreds of miles away. It takes some of the most powerful and advanced tools humanity has ever built. Our understanding of this system has been pieced together over years, like a great cosmic detective story. The first clues dropped back in 2013. Then in 2015, we got the smoking gun, an actual picture of the protoplanet. And more recently, in 2020, the ALMA telescope gave us those stunningly detailed images of the disk, showing the gap and those beautiful spiral arms. Every new look adds another piece to the puzzle. So these are our cosmic eyes. You've got the Very Large Telescope, or VLT, which uses a special instrument that's basically an expert at blocking out the star's glare so we can see the faint little planet next to it. Then there's ALMA, which doesn't see visible light. It sees the cold glow of dust, which lets it map out that whole cosmic construction site in amazing detail. And of course, the good old Hubble Space Telescope is in there too, grabbing other critical pieces of data. Together, they give us the whole picture. So after all this, a giant, weird planet super far away with crazy long nights, we come back to one simple question. Why should we care? What does it have to do with us here on Earth? Well, it matters a lot, because this planet is like a time machine that gives us a peek into our own very distant past. What it comes down to is this. The HD 10546 system is our own personal cosmic laboratory. It lets us watch planet formation happen for real, not just in a computer model. We can test our biggest theories and get real data to see what's right and what's wrong. And by doing that, we get a priceless look at how our own neighborhood giants, Jupiter and Saturn, probably got their start billions of years ago. So if you remember anything, remember this. 1, we are watching a colossal super Jupiter get built right now in real time. 2, it lives in this totally bizarre world defined by endless nights and insane weather. And 3, and this is maybe the most important part, it's our best snapshot yet of how the giants in our own solar system were born. And that leaves you with one last, really exciting thought. This one system, this single planet being born, has already challenged so much of what we thought we knew. So it really makes you wonder, if this is how these giants are made, what other secrets, what other strange and amazing worlds are taking shape right now in those distant stellar nurseries, just waiting for our eyes to get sharp enough to find them?